Hi guys, these are some problems that were brought up to me earlier today, so I wanted to go through them with you. I think they might actually be relevant for your quiz. So we have to evaluate these two limit problems. So I think these are slightly trickier problems and I haven't actually talked about them in my other videos. So I'm just going to jump right into them. So first things first, this problem here, so just by looking at it, so I've got 2x to the 6 plus 3x squared minus 1 over 6x cubed minus 2x plus 1. This is absolutely going to either positive or negative infinity. Do you agree with that? So the dominating term, the x to the 6, it is in the numerator. So the numerator is growing way faster than the denominator. So that tells you this is definitely going to end up at infinity. And we're not being asked to find the oblique asymptote. So this is a trick I haven't actually kind of talked about, but I want to go through it with you. So before I show you the trick, I just want to talk about what happens when I divide by x to the 6. What will this look like? I'll write that out really quickly for you. Okay, so I wrote this out in just this yellow color to help make my point. This is not the actual answer. So think about if you actually were to evaluate this. So we can see a problem with this, and this is kind of telling us like you might have to do some long division or something if that was the question. But this would ultimately give me a denominator. The entire denominator would entirely go to 0. These parts would go to 0. So all of this would leave you with 2 over 0, right? Because you have this constant right here. So not helpful, right? That doesn't actually tell us the answer. So we can be a little bit more clever now in how we divide. So let me clear this out. And so here's like a way you can kind of game this without having to do the long division. Instead, you can choose the highest power in the denominator, which would be x to the 3rd. So now I want to say divide by x to the 3rd. So I'm going to go ahead and just work that out. Okay, and so there we go. I divided each part by x to the 3rd. So in doing that, this part here becomes 2x to the 3rd. But look at what it kind of does to the rest of the problem. So I don't end up with a 0 in the denominator by this very clever choice. So these parts here, these all go to 0. These all go to 0. And now I can just think through, well, what happens as x goes to negative infinity? Well, really, I just have to think about that I'm plugging this in x to the 3rd. So if I take something negative to the 3rd power, is it going to stay positive or negative? It's going to stay negative, right? So in this case, this will equal negative infinity. Boom, done. So that's like another way you can kind of approach this that I know I haven't mentioned before. Okay, so for this problem, this one's going to be a bit of a party. So you've got the limit as x approaches infinity of 5x to the 8 over 3rd minus 3x to the 5 thirds plus 2, and then this is x to the 13 over 5, and then 2x minus x to the 1/2. So there's just a lot going on here. So I want you to kind of notice that these exponents are kind of here as distractors. It's still the same idea. So you'd still want to think about like what's the actual highest power that we're looking at. And if that's not immediately obvious, you know, one way that you can handle this is you can just get a common denominator for all of the fractions. So I've got the denominator of 3, 5, and 2. So the denominator that I would need here, so kind of the LCD, would be 30. So let's go ahead and just rewrite all of these with the denominator of 30. So I'm going to go ahead and do this. If you want to pause and do that yourself just to follow along with me, go for it, and I'll meet you there. Okay, so I just rewrote all of the exponents so that they all have this common denominator because it just makes the comparison easier. Now, I can see just from looking at this that the highest exponent is actually in the top, but this doesn't always happen. So I actually want to be a completionist about this, and I just want to take a moment to say, what would happen if I divided by the highest power in the denominator? What would this look like? So I want to kind of just clear everything out to make this a little nicer. So the highest power in the denominator is this x to the 78 over 30. So this is what I want to go through and divide everything by. So let's set that up. Okay, so you can see now that I've set this up, this will just allow me to really do the subtraction very quickly. So it is a little bit more work, and I know it's just kind of more to look at. But now what I'm going to do is I'm going to go through and I'm going to do all the subtraction, and then I'm going to rewrite kind of these answers in their most simplified form. So let me clear some space. And I'm going to kind of omit some of the details here in all of the reducing. So like this is going to give me, so 80 over 30 minus 78 over 30 will give me 2 over 30. So I'm just going to write this as 1 over 15. So I'm going to write this in its simplified form. So if you're playing along at home, just note that. So I'm skipping kind of that step. So let me write out now how all of this will simplify. Okay, and so now I've written this in this simplified form, and this is really going to help me very quickly kind of figure out what I need to do next. So in dividing actually by the highest power in the denominator, so look what I've actually done. So the bottom here, this part, well, this limit as x goes to infinity, this is going to go to 1, right? This part right here will just go to 1. While these two pieces here, as x goes to infinity, these are going to go to 0, right? So this is good because then we don't have infinity in the denominator, so we won't have that indeterminate form. Now, these two right here, these are both going to go to 0 as well, right? So these are both going to 0. So that just leaves us then with what is happening here. So as x goes to positive infinity, this is just going to stay positive, and it's just going to end up going to infinity. So I can see kind of what the behavior of this is, and I don't have any question about it now, and I don't have an indeterminate form. So I have this kind of in that perfect spot. And so since it's already positive, there's no reason this is not going to stay positive, so this is just going to equal positive infinity. Now this doesn't always work out like this. Sometimes you might actually have that the higher power would be in the denominator, and then you'd have to refigure out what happens in that case. But this is kind of how you handle problems that have these crazy exponents in them. Okay guys, so that's the two problems I wanted to go through in this video, so thanks for watching. I'll see you guys next time.